Hello, welcome to my channel. In class 12th, in the topic Magnetism and Matter, we have discussed in the previous video the diamagnetic substances and its properties. Today, we will discuss the paramagnetic substances and their properties. What are paramagnetic substances? The atom of paramagnetic substance in an ion or molecule, it possesses some atomic magnetic moment, that is the magnetic moment of all the electrons. It is not add up to 0. That's why each atom in the ion or molecule of a paramagnetic substance has the net magnetic moment. We can represent like this, that suppose in the bulk of substance which has been taken as a said to be paramagnetic substance, this is the atom and it possesses magnetic moment. Suppose this is the magnetic moment. How can you say that this magnetic moment is possessed by the atomic each atom? That's why they are called atomic magnets or magnetic dipole. It is so because of the unpaired electrons. Unpaired electrons in each atom, they produce their magnetic moment like this. Even then, what happens that each atomic magnet has its magnetic moment in different direction. So we can say that despite of magnetic moment possessed by each atom, in the bulk of material, when they are taken, net magnetic moment of that bulk of material remains 0. What we can say, that although each atom has the magnetic moment, each atom is behaving like the magnetic dipole, but in bulk, due to random orientation of these atomic magnets, net magnetic moment of the bulk of substance is 0. So these are paramagnetic substances. Their examples are aluminium, sodium, oxygen, calcium and so many. And this magnetic moment is present due to presence of unpaired electron in the atom. What happens that these paramagnetic substances, when they are brought near the magnet, feeble attraction, magnet attracts it feebly, and they have tendency in non-uniform field to go from weaker to stronger part. So what are paramagnetic substances? We discussed, and this tendency to be attracted by magnet of paramagnetic substances and to shift from weaker to stronger part in the non-uniform magnetic field, this is called paramagnetism. Each atomic magnet is a magnet. Despite of that, in the bulk, no net magnetic moment is said to be present. What happens if any of the substance, I am not talking about para or dia, if any of the substance is placed in magnetic field, these 2 points, number 1 and this number 2, they are the points of consideration. That what happens, that atomic dipoles of the substance orient in the direction of external magnetic field. Suppose in the bulk of substance, these are the atomic dipoles. Atomic dipoles means those atoms having magnetic moment in a certain direction. These atomic dipoles, they are present in paramagnetic substance. So they will have tendency to orient themselves in the direction of magnetic field. Why? Because we have read that a magnetic torque will act on the atomic dipoles. Atomic dipoles have magnetic moment m and magnetic field, external magnetic field applied is V. Then what is the role of this torque? This torque tends to orient them in the direction of magnetic field. What about the second case? When any of the substance is placed in external magnetic field, due to the induction effect, which we have discussed in the diamagnetic case also, that whenever the external magnetic field is applied, some of the atomic dipoles are induced. Dipole moment is induced in the direction opposite to the applied magnetic field. And this induction effect is due to Lenz's rule, which says that is induced current opposes its cause of production. So what happens that few of the atomic magnets will induce in the opposite direction of external magnetic field, and it happens in all substances. Like we have seen in diamagnetic substances, there were no atomic dipoles, only second point was applicable. So we have seen that diamagnetic substances were feebly repelled by the magnet, and they have feeble magnetization when placed in magnetic field in the direction opposite to that. What in case of paramagnetic substances? Since they have atomic dipoles, although they are randomly oriented, but in a bulk of material, the atomic dipoles, when they are placed, that material is placed in the external magnetic field, then the action of torque tends, this torque tends to rotate to align each atomic dipole in the direction of magnetic field. So this is the origin of paramagnetism, and which type of substances, what are the examples we have seen. Now what happens that the alignment of these atomic magnets, if we have to see, then on the basis of presence of magnetic field and their magnetic behavior, I have written here that magnetic behavior is observed in absence of magnetic field, in presence of magnetic field, and in presence of non-uniform magnetic field. How to learn for any of the substance, what are their properties. Suppose we see that a bulk of the material is shown here. All the atomic magnets are randomly oriented. So when external magnetic field is not applied, so net magnetic moment is 0 due to random orientation. So due to randomness of the atomic magnets, net magnetic moment is 0, but when the magnetic field is applied, that substance of paramagnetic substance is placed in the magnetic field. What happens? Suppose this is the direction of magnetic field, I am showing like this, then few of the atomic dipoles, not all but few, have tendency to be directed, to be oriented in the direction of magnetic field. What happens? This orientation can be increased by increasing the strength of magnetic field. So in this way we can say that if the applied magnetic field increases, then magnetization also increases. How it can be increased? By decreasing, lowering the temperature. How? The magnetization can be increased by increasing H, magnetic intensity, and also it can be increased by lowering temperature, because decreasing temperature means more is the alignment in the direction of magnetic field. So we can see that whenever the paramagnetic substance is placed in magnetic field, it shows the feeble magnetization in the direction of magnetic field, hence it is feebly attracted by a magnet, and the magnetic field lines, suppose we say that we read the properties of paramagnetic substance in terms of magnetic field and non-uniform, uniform magnetic field. What can you say? That in the discussion of properties, how will you learn that first each atom of paramagnetic substance is a magnetic dipole, and second property, when B external is not there, in absence of external magnetic field, in absence of external magnetic field, despite of each atom being a magnetic dipole, the net magnetic moment of bulk of the material or bulk of the substance is zero. Why? Due to random orientation of each atomic magnet. Like this. That's why magnetic behavior in absence of magnetic field, what we can say, they don't show any magnetic behavior, any magnetic attraction in absence of magnetic field. What happens in presence of uniform magnetic field? In presence of uniform magnetic field, we have seen, suppose this is the uniform magnetic field. For a small region, we have shown equidistant parallel lines. If a rod of paramagnetic substance or the piece of paramagnetic substance is placed, what happens? The magnetic field lines becomes, their presentation becomes like this. They tend, the magnetic field, the presence of magnetic field within the substance become more than outside. So, it is said that the permeability of paramagnetic substance is more than the permeability of free space. So, susceptibility, permeability, these are the points through which we learn the properties. By knowing these terms, we know these terms are very important, but by knowing these terms we can learn whether the permeability of free space will be more or the permeability of paramagnetic substance will be more. What happens in non-uniform magnetic field? If they are placed in non-uniform magnetic field, what happens? The paramagnetic rod is aligned in the direction of magnetic field. Suppose this is the north and south pole of a magnet, and if you suspend a paramagnetic rod freely, then it aligns itself in the direction of magnetic field. So, in absence of magnetic field, in presence of uniform magnetic field, in absence of magnetic field, this, in presence of uniform magnetic field, this one, and in presence of non-uniform magnetic field, this one. They have tendency to shift from weaker magnetic field region to the strong magnetic field region. You can also show that if the substance of paramagnetic substance is taken in the solution form and is filled in U tube, and one of the side of U tube is placed under the effect of magnetic field. Then what happens in that arm? The level of solution rises like this. It shows the tendency that the paramagnetic substance shift from weaker to stronger region of non-uniform magnetic field. Now what about the intensity of magnetization or magnetic moment per unit volume? We know this intensity of magnetization is represented by I or M, and we have read the relation of M and H. What is that? Intensity of magnetization is directly proportional to the magnetizing field, this H, and it is equal to that constant. This is called magnetic susceptibility. What is M and H here? We see that if a paramagnetic substance is placed in magnetic field and you increase the magnetic field, intensity of magnetic field is increased, what happens? On increasing the magnetic field, if B increases, then torque is also more. Then more torque means more is the orientation in the direction of magnetic field. So what can we say? That if a graph is plotted for I or M, whatever you can say, for intensity of magnetization, and H, more will be the field applied, more will be the magnetization as per this point. So the graph will be like this. These are the questions asked for the substance, paramagnetic substance. You draw or the curve is plotted, you have to say that whether this curve belong to paramagnetic or diamagnetic substance. Now, okay, now see what about the susceptibility. Again from the same relation, we know that susceptibility is the measure. You have applied the magnetic field, but how much magnetization occurs in the atoms of paramagnetic substance, that measure is susceptibility. In case of paramagnetic substances, the susceptibility and magnetization H are related with this. So what can you say about the susceptibility? That this susceptibility is, since M is proportional to H, then M equal to psi H. So you can write here the psi is M upon H, and it depends on temperature for paramagnetic substances. How can you say that? If temperature lowers, temperature is decreased, then more and more orientation takes place in the direction of magnetic field. So the temperature and susceptibility graph is, we can show here with the help of graph like this. This can be discussed in terms of effect of temperature for diamagnetic substances. So more is the temperature, less will be the susceptibility. Susceptibility or magnetization or intensity of magnetization. What can we say here? This is for M as well as for intensity of magnetization I. So we can say here that what are the susceptibility relations with temperature. Now what about relative permeability? In case of paramagnetic substances, we can say that the susceptibility, the relative permeability, we know that relative permeability is 1 plus psi m. Since this psi is for paramagnetic substance, this psi is small and positive, we have seen, then mu r is also, we can say, less than 1 plus very small number any one. but it is greater than 1 always and positive. What about permeability? We have seen that magnetic field lines have tendency to pass more through the substance. When the paramagnetic substance is placed in magnetic field, the magnetic field is dense in the substance as compared to outside. What does it mean? That permeability of paramagnetic substance is greater than that permeability of free space, because more field lines tend to pass through the material. What about the effect of temperature? This is very important point for the paramagnetic substances. Look here that we have seen the magnetization can be increased by increasing the field strength and by decreasing the temperature. Look again that this magnetization can be increased by increasing the field strength and by decreasing the temperature. That is like this. This is magnetization versus temperature, which you can also say about the susceptibility too. You can relate. What happens in case of paramagnetic substances if the applied magnetizing field and temperature, their ratio is taken, that is called H upon T, and a graph is plotted. It is observed experimentally. Now, what is the effect? What is the variation of magnetization versus H upon T? So, it has been observed, look in this graph, that if H upon T value is not too large, then the graph is like this, which shows that till the graph is a straight line, the proportionality exists. That region is called Curie region, Curie Law region, Curie region, and beyond that, what happens for the larger value of H upon T? Magnetization reaches up to the saturation. What is the meaning of this? Suppose we have applied the magnetic field, then few of the atomic magnets are still not in the direction of magnetic field completely. They have certain magnetic direction other than the applied magnetic field. This is the magnetic field region H. If applied magnetic field is increased, then orientation increases. What happens when 100% orientation is done, that is on such value of magnetic field applied, the all atomic magnets, they have orientation in the direction of magnetic field. This is called the stage of magnetic saturation. Then what happens on decreasing the temperature? Nothing is going to change. Already all the atomic magnets are oriented in the direction of applied magnetic field. So, at this stage, the magnetization becomes independent of T. Whatever the value of T you lower, magnetization is already 100%. So, this susceptibility or magnetization is not dependent on T, and at that point the important law, that is Curie law, become invalid. And what is Curie law? Look, Curie law of describes the temperature dependence of paramagnetism. What does this law says? That far away from saturation, the magnetic susceptibility of paramagnetic substances is inversely proportional to absolute temperature. This law holds so long as the ratio of H upon T is not too large. that is when magnetization, intensity of magnetization approaches the saturation value, 100% of alignment, 100% alignment of atomic magnets is achieved. So we can say that magnetization is directly proportional to intensity of the magnetizing field and inversely proportional to absolute temperature. These are the two parts of the Curie law. And what are the limitation? And there is single limitation, that the law holds so long as the ratio H upon T is not too large, that is when magnetization, intensity of magnetization approaches its saturation value. This M directly proportional to H upon T. In words, what you will say, Curie law, that for paramagnetic substances, the intensity of magnetization is directly proportional to the magnetic intensity and inversely proportional to the absolute temperature. Then you will write M is proportional to H upon T, this is H, and M equal to C into H upon T. This C is called Curie constant, and this M is equal to CH upon T. And we have seen that M cannot increase without limit. So we have seen this is the magnetic saturation stage, and here this Curie's constant, this M can be, how can you write in some books, instead of M it is this law, Curie law, same law is written in terms of magnetic susceptibility. That's why I am showing here. You know M equal to psi H, this is susceptibility into H. So what will you write here? This is susceptibility into H equal to CH upon T. So this H is cancelled. So this is susceptibility equal to C upon T. What can you conclude here? That susceptibility is 1 upon T. So don't get confused. What is Curie law? You can say magnetization, intensity of magnetization is directly proportional to H and inversely proportional to absolute temperature. You can say for far away from saturation in the magnetic susceptibility of paramagnetic substance, that magnetic susceptibility is inversely proportional to 1 upon absolute temperature. This is magnetic susceptibility. This I have shown here. Magnetic susceptibility is inversely proportional to the temperature. Limitation, that beyond saturation region, this psi or M, whatever you can say, is independent of this temperature. It becomes invalid. Curie law becomes invalid after this, when this is very large. So for the large value of H upon T, Curie law becomes invalid, and this region where M is directly proportional to H upon T, this is the Curie law region, and here this is the saturation region. So in this way you can learn the properties of paramagnetic substances and their behavior in magnetic field and in absence of magnetic field, effect of temperature. This total we have read today. I hope you must have enjoyed. Thank you.